What's up, everybody? In this video, we're going to learn how to solve USACO's 2020 February bronze problem number 2, mad scientist. Let's read the problem together. Farmer John's cousin Ben happens to be a mad scientist. Normally, this creates a good bit of friction at family gatherings, but it can occasionally be helpful, especially when Farmer John finds himself facing unique and unusual problems with his cows. Farmer John is currently facing a unique and unusual problem with his cows. Fine. He recently ordered N cows, with N being up to 1,000. So that means that he will have up to a maximum of 1,000 cows, but perhaps fewer. It says it's between 1 and 1,000. We don't know yet. Recently ordered N cows consisting of 2 different breeds, Holsteins and Guernseys. We're going to run into these 2 different breeds of cows a lot in different problems. Holsteins and Guernseys. He specified the cows in his order in terms of a string of N characters, either H for Holstein or G for Guernsey. Okay, so when he made an order, he specified it with a string, that's just a sequence of letters, with either H or N. So we're expecting that when he, H or G, excuse me, H or G. So we're expecting that we're going to have some sort of an order that looks something like this, where it's a sequence of H's and G's. Potentially, depending on the order, it could be all H's or all G's, but most likely for most of these problems, it's going to be mixed up. However, when you do write your code, you do have to take into consideration that probably one of the test cases is going to be all H's. They're just going to make sure you don't handle that incorrectly. Unfortunately, when the cows arrived at his farm and he lined them up, their breeds formed a different string than his original string, right? Okay, so this is going to be like his order, but then his actual cows are going to be like H, H, G, 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 H, H, or something like that. Let's call these 2 strings A and B, where A is the string of breed identifiers Farmer John originally wanted, and B is the string he sees when his cows arrive. Fine. Okay, so we're just giving letters to these. So the order is going to be string A, and then what he actually got is going to be string B. Rather than simply check if rearranging the cows in B is sufficient to obtain A, Farmer John asks his cousin Ben, the mad scientist that has problems at family gatherings, his cousin Ben to help him solve the problem with his scientific ingenuity. All right, let's scroll down. That looks good. Let me get the N. There we go. Perfect. All right. 1 second, let me clean that up. Okay. After several months of work, picking up here, Ben creates a remarkable machine, the multi-cow breed Flippinator 3000, apparently, that is capable of taking any substring of cows and toggling their breeds. All H's become G's, and all G's become H's in the substring. Let me read that again. It's capable of taking any substring is like part of a string, substring of cows, and toggling their breeds, toggling just meaning to flip. So the G would become an H, this H would become a G, this H would become a G, and this G would become an H. All his H's become G's and all his G's become H's in that substring, in the selected substring that he's flipping. Farmer John wants to figure out the minimum number of times he needs to apply this machine in order to transform his current ordering B into his original desired ordering A. So we're going to try and change this into that by flipping subsequences. Sadly, Ben's mad scientist skills don't extend beyond creating ingenious devices. So you need to help Farmer John solve this computational conundrum. All right, input format. Let's read over this real quick. So the input format is that there's going to be a file you have to read called breedflip.in. And in that file, the first line of input contains N. Here's the sample input down below. First contains N, that's how many cows there are. So in this example, there are 7 cows. The next 2 lines contain strings A and B, right? A and B. Each string has N characters that are either H or G, right? N characters. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And they all have only H's and G's. And we can trust that we're not going to have any weird input. They're not going to give us any lowercase characters or any letters that are neither H nor G that we have to worry about. They're not going to give us strings that are longer or shorter. We can always trust that they're going to give us exactly what they say they will. The output format, you will have to write the output to a file called breedflip.out. And we're supposed to print the minimum number of times the machine needs to be applied to transfer B into A. All right, let's write down the sample problem first, and I'll give you guys a minute to think about that while I'm doing that. G, actually, let me clear this out here. G, H, H. We're trying to produce H, H, G, 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 H, H. All right. And I mentioned this in my other videos. If you don't have paper and pencil by your desk, I recommend always keeping a paper and pencil by your desk. And if you want to take a minute to think about this problem and try and work it out, now's a good time to do so. Oops. Feel free to pause the video if you want to take a minute to think about it, and then we'll move on with the example here. All right. So we have to turn this into that. So what we're looking at is we're looking at how do we flip in a way that's efficient. So for example, would it ever make sense to flip this subsequence right here, like a long subsequence and then a short subsequence? Let's try it with just this example and see what we got. So G is incorrect. So I would want to flip G. That's one flip. The H is correct, so I wouldn't want to flip that. Or I would want to make sure I flip it twice. The next two H's, HH versus GG, those are not correct, but then the G's are correct. So we'd either need to flip them twice or flip them 0 times. And actually, it looks like the rest of this actually also matches up. So let's look at just this example. I've got 2 sections I need to flip, one section here and one section here, but I can't flip this piece in the middle. Now, this actually, understanding this part right here is going to be the key to solving this problem. Would it be better to flip this section here, which is one flip, and this section here, which is a second flip? Or would it be better to flip the entire sequence all the way here to here, which is one flip, and then flip this one a second time to set him back to H? And that'll work either way. But if you think about it, that's 2 flips either way. So let's try different combinations and see if that's always going to be the case. Let's say like I have G, H. Let's actually do all G's and then just mark H's in the second one. We'll go G, 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 G. And let's say like I have, I want to have G, H, G, G, H. Actually, let's do it the other way around. Let's have H, G, H, G, H, H, G, H. Okay, so the ones I'm gonna have to flip are gonna be this one, these 2, and this one, which would be 3 flips. So what would happen if I were to flip the entire thing? That'd be 1 flip, and then fix this one, and fix this one. You can see even with 2 that are out of position, it still adds up to be the same. Either I'm flipping the whole string and then correcting these, or I'm flipping the individual segments. Now, if you think about the mechanics of this, let me clean this up again. If you think about the mechanics of this, essentially what's happening is if you have a segment that needs to be flipped, I'm just going to mark a square where I need to do the flipping. So I'm going to say I need to flip this segment, I need to flip this segment, and I need to flip this segment. In any situation where I have segments where I need to flip and segments where I don't need to flip, no matter how many of those not needing to flip segments there are, 1 and 2, no matter how many of those there are, if I flip the entire sequence and then flip those back, that's always going to add up to exactly how many turns it would take to just flip the sequences that are out of order. We can try that with, let's try that with a larger number than 3, just to really kind of hammer that point in. So like I have, this needs to flip, this needs to flip, this needs to flip, this needs to flip, this needs to flip. So I would have 1, 2, 3, 4, 5 sections that need to flip. Or if I were to flip them all and then have to fix the spaces, I have 1, 2, 3, 4 spaces to fix, plus the 1 flip, which still equals 5. So whether I flip the entire sequence and then correct the ones that were originally right, or whether I flip only the wrong sections, I get the same result. As far as writing code to solve the problem, it's probably easier just to count the segments that are incorrect. So really all we need to do to solve this problem, I'm gonna clean this up one more time. All we need to do to solve this problem is start a counter, maybe like I equals 0, and run it through this sequence. Every time you have a section where it was wrong, that counts as 1. So this is 1. And then we advance. Those are right, so we ignore that. That's wrong, so that's 2. Now, since this is also wrong, anytime you have a sequence where many things are wrong in a row, that still only takes the same flip. So as long as it continues to be wrong, we can keep advancing without increasing this counter. So I had 1 for this one being wrong, and then this one was right. I had 1 for this one being wrong, but then this one also was wrong, and that didn't cost me anything. I got back to this one being right. That one's right. That one's right. My final answer on that string is 2. Let's double check. Oops. And the sample output is expected to be 2. All right, let's try with a couple more strings and see if it makes sense. I'm going to do a little bit longer of a string. So it's like I have G, H, G, G, H, H, G, H, G. And then let's say like I have H, H, G, H, G, G, H, H, H. Okay, now one thing you can do that also might make this simpler is rather than processing G's and H's, you may want to create an array of Booleans that's just true and false, whether or not they are already correct or whether or not they're backwards. That might just save a step. It's not necessary to do. It actually probably would run a little faster not to do it this way, but it might be a little easier to visualize. And since we mentioned before n is equal to 1,000, and we're doing this in a single pass, we don't really have to worry about the code running too slowly. We're very well within our accepted time complexity on this. It's a linear solution since we don't have to go back and look at anything again. We can do it just in one single run through. We only have 1,000 things to run through. Realistically, we could get this all the way up to about 10 to the 8th without too much difficulty, which would be like 1, 2, 3, 4, 5, 6, 7, 8. And we'll talk more about time complexity when you get to silver. But even with a string of n equals 100 million cows, we still should be able to process this without too much trouble. So n equals 1,000 should be easy. Okay, so if I were to do that, then this would be, let's say, false because they're different, and then true, true, false, 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 true, and then false. So essentially what you're doing is every sequence of falses where the cows are not correct, we have to count that as 1. So my counter is going to start at 0. And let's have another thing that just says like whether we have found an error, which error will equal to false. Okay, so anytime we hit a false, I'm going to set error to true. And then as long as error is true, I don't have to add to my counter as I continue through the sequence. So I hit a false, those are not correct. When that happens, I'll switch error to true. Let me actually make the second one wrong as well, just to make it a little more clear on what's going on there. We'll go HGG, G, and that one also can be false. Okay, so first one is a false, which means we set error to true, and we add 1 to our counter. Second one is false. Since error was already true, we don't have to make a note of this in our counter. Our counter stays at 1. Here we hit true. When I hit true, I'm going to set error back to false because I no longer have an error. Here I hit a false again, means that one was an error. Because that's an error, I'm going to set error back to true. I'm going to increase my counter to 2. Here's another false. That's also an error, but error was already true, so I don't have to change my counter. This one also was incorrect. Error is already true, so I don't have to add to my counter. This one was also incorrect. Error was already true, so I don't have to add to my counter. I hit a true. That means it's no longer an error anymore. Error will switch back to false. Then I hit another error. Switch error back to true. Add my counter to get to 3, and then I've reached the end of the string. Total number of flips necessary was 3. And we'll just check that again, just kind of eyeballing it to see. I would have to flip this segment right here for those 2 cows. I would have to flip this segment right here. That would be 1 flip, and I would have to flip this right here. That's your 3rd flip. All right. Good luck coding it, and I'll talk to you on the next video.